Good afternoon, ladies and gentlemen. Sorry, I'm going to speak English, I'm afraid. My name is Stefano, and I'm going to talk with you about the specific architecture that we at Adtran have implemented since 2015 in our Access OLT, which is delivering actually very interesting results and benefits to our customers. So, before delving into the specifics, the technical specifics of our OLT, let me just give you a short peek about who are we at Adtran. So Adtran is an American-European company which delivers end-to-end network equipment. The headquarters in America is in Huntsville, Alabama, but we have an extensive presence in Europe. Actually, half of our 3,000 employees are located in Europe. And basically, more than half of our business is in Europe. Not only we are interested in Europe, but we have also a strong presence in Poland. And that's why we basically heavily invest also for the future to support this country's ambition. So basically, we have a 20+ years history in Poland. As you can see, we keep hiring people even after the merger between Adtran and ADVA. We started in Poland as ADVA, now we are Adtran, and we still keep investing not only in terms of number of R&D and support teams, but also in terms of facilities. So we have an important center of excellence in Gdynia, where we can test. We actually do a lot of testing for our customers, and we normally test not only Adtran equipment, but also third-party equipment. So that's about us, and a little bit more on our portfolio. It's really end-to-end. We have our subscriber solutions and also our enterprise solution. So we have fiber access, carrier Ethernet, Wi-Fi, and a residential gateway. And also we have business class routers and switches, and IoT solutions, and also the platform for network virtualization for enterprises. Also, we have the optics part, so direct access to fiber with an aggregation, of course, network timing, synchronization, and also the optical networking solution, which is more transport, as you can imagine. We also are very serious about security, and which is at the heart of all our product development. We also have our, let's say, vertical business, which are cross to all our portfolio, so the platform, software platform, and also our professional services, which are also located in Poland. This is just the view from the more, let's say, more usual end-to-end network portfolio. So today, I'm going to focus more on the optical line terminal and ONT. So I'm talking about fiber access, fixed fiber access, and fiber monitoring solutions. Before delving into our OLT, let me just show what are the trends on FTTH and what are the implications of these trends for the network engineer. So first of all, where is Poland in the big map of the European coverage with FTTH or FTTB? So if we talk about coverage, Poland is not bad. Actually, as you can see, there are, let's say, 3 areas where there is some excellence. Let's say the pioneers are Western Europe, Northern Europe, and also the Black Sea region, if I can say that. But after these pioneers, there are some countries like Poland, which are trailing behind. So today, the FTTH coverage in Poland is 60%-ish, and the forecast is that the coverage will reach more than 80% by 2029. If we talk about actual customers of FTTH, so the penetration is the ratio of subscribers to FTTH as a percentage of households, then of course there is more work to do. Today, the FTTH service penetration in Poland is at 25%, and the forecast is that by 2029, 41% of the total households will be connected to an FTTH service. So, like many other parts of Europe, a lot still has to be done in order to connect the people to real FTTH services. So what are the implications of all of this to the network engineer? Well, it's going to be a lot of bandwidth, in terms especially in terms of uplinks. So here I have just made, let's say, generic calculation, taking 3 different scenarios: the slow growth, the average growth, and the fast growth. And so, of course, we can discuss about it. You can show us your specific data, but let's say that on average, the GPON pipe is going to be full by 2030. And when I say full, I mean that the whole 2.5 giga will be completely full in terms of traffic. Also, before that, there will be a moment when the speed test will not reach 1 gigabit. So this is important for the marketing, of course. We know that there are no applications that really need a gigabit, but sometimes our customers, like clicking on the speed test to enjoy seeing the 1000 megabit number and be happy, maybe post it, So from the marketing perspective, not reaching the 1 gigabit is a problem. And this is going to become true before 2030, like, for example, in 2027. Also, on the uplink side, that's going to be more important for engineering. So I just made an example of a 48 PON unit OLT, which will need more than 100 gigabit by 2030 and more than 200 gigabit by 2033. So the bottom line here is you, as operators, have to be flexible enough, your solution has to be flexible enough to be ready to allocate possibly a non-blocking bandwidth, looking, of course, in the future. It's not a problem that you are going to face now, but you better think about it, because it's going to arrive sooner or later, and probably sooner more than later. So this is the consideration for traffic growth. Of course, we are happy at Adtran to support you. We are there at our booth. We can discuss if there is anything that we can do more for you in terms of, let's say, characterization of your specific situation. Also, well, very, very fast on the cost of energy. My only point here is that there is a risk of another cost surge in the energy price, which simply the operator cannot control. So it is important to have a very, very low power consumption OLT. So which are the implications of what we have seen for the access OLT? Well, first of all, it's needed some simplicity, because a simple OLT means that is faster, the deployment is faster, and it is cheaper, and it is simpler, and the warehouse is not too complicated to be, to be managed. It is very important that there are no roadblocks to deployment of the OLT. Then, of course, has to be also flexible. Why? Because nobody knows what is going to arrive. So, like I said, the uplink bandwidth is going to grow, and we better be ready to do it. But also, new PON technologies are going to arrive. And of course, now we are all happy with GPON. We know that XGS PON or 10 gigabit PON is going to arrive at some point, possibly, as we have seen, probably before 2030. Then there is also the 50 giga PON, and also in the long term, very long term future, the 100 gigabit PON. So I'm not telling you that all of this is going to be needed now. But what I'm telling you is that your OLT should be ready to evolve to those standards without being chucked, without you being forced to chuck it because it doesn't support them anymore, because it is too old. I mean, it has to be, let's say, maintained through the years. And of course, talking about efficiency, it has to be let's say, with minimum power consumption and with a very, very, very small footprint so that it doesn't waste AC, for example. So these are, let's say, in general, the market requirements to the OLT. And so at Adtran, we have thought, these trends, to be very honest with you, were clear even before today, right? So at Adtran, we have started thinking critically at the standard legacy chassis-based OLT, if it was fit to sustain these challenges. And actually, it turns out that it isn't. Okay, at Adtran, we do build, still the chassis-based OLT alongside the disaggregated OLT. But to be honest, in Europe, we only sell the second one, the disaggregated one, because it is better. And I will explain you why. First of all, let me explain you why the traditional chassis-based OLT is not the best fit for those challenges. First of all, okay, let's agree on what it is, the chassis-based OLT. Is an OLT with a chassis, a backplane, some common parts, the matrix or aggregators, however you want to call them, which are needed, all the common parts are needed, and some line cards, which contain the PON access or the point-to-point fiber access. Okay? So, in our opinion, this architecture is not good enough, because, first of all, it is not simple. You need to have the chassis, the common parts, and so on, and so on, and so on, to be able to just start the PON service. And also, there is a full vendor lock-in. It's a nonsense asking, having an OLT of vendor X and asking them to put the line card of vendor Z because they are better. There is no way, right? So it is a full vendor lock-in. Also, it is not flexible because it doesn't scale beyond the dimension, the physical dimension of the chassis. And also, when the new PON standards will arrive, there will be restrictions. That usually is the case because, not because the vendor is bad, but just because the backplane technology is outdated. It doesn't support the backplane bandwidth which is needed to deliver full performance of 50 gigabit PON, and this is a problem. Also, it doesn't adapt to new topologies like ring, cascade, ring of cascade, cascade of rings, stars. All these topologies are very important to address rural communities. We'll see an example about that. Also, it's not efficient. Why? Because normally, and I have worked 8 years in the operator business, what I was doing as an engineer in the operator was always buying the biggest chassis. Why? Because the market, at some point, I knew that would ask me for more PON ports, okay? And so we wanted to be safe in the engineering department, and so we had to buy the biggest chassis. It's fine, but what usually happens is that the big chassis is left, half empty, and this wastes money, space, and energy. So these are the reasons why, in our opinion, the chassis-based OLT is not fit to withstand those challenges. So what is fit then? In our opinion, a new architecture of the OLT is needed, which we call, is a common name, disaggregated OLT. And to be honest, is not our idea, okay? Quite frankly, is a data center type of idea. If you are kind of acquainted with the data centers, you will see that they are full of pizza box instead of chassis-based equipment. Why? Because they are more efficient and because they scale better. So that's the same concept that we have applied with the OLT. So the chassis-based OLT and the disaggregated OLT functionally deliver the same type of service. Okay? They are the same. But the difference is in the architecture, in the physical architecture of the node. So how is the disaggregated OLT built? It's built on data center-like appliances. So each appliance is completely self-sufficient. So you just plug the appliance into the 48-volt power source, and it just works without needing any other common parts, you know. Then each appliance is specialized on one purpose. So there are PON access appliances, Ethernet access appliance, if needed, and aggregation high-capacity appliance, if needed, of course. So only the PON access appliances are the one really needed in every case. The other two are, let's say, case by case, has to be seen, right? So the OLT platform is built by physically connecting with standard Ethernet cabling those appliances that are needed. And this is really a step change. Let me show you better what I believe. And here you see a list of the operators, or say the tier 1 operators, that in Europe and in the US have embraced this technology. And actually, just for you to know, today we have delivered enough disaggregated OLTs to cover 20 million households in Europe. Okay, so we cannot just talk about innovation anymore, it is a reality. So normally, you would start with some access appliances. So one OLT leaf is enough to start to deliver PON services. Then, of course, a leaf delivers not more than 48 PON ports. What happens when you exceed this number? Very easy. You cascade, or you, let's say, connect by star a few of those OLT leaves. And this will increase the number of, scale very much higher, the number of PON ports. Then, of course, you can tell me, oh, but Stefano, we need also some point-to-point connections. That's absolutely possible by inserting an Ethernet point-to-point leaf. And, of course, you could tell me, but we have to connect all the uplinks to our switch routers. We need some aggregation. This is also possible by inserting some high-capacity aggregation appliances. And also, in the specific case that you are a wholesaler, you might need some low-capacity uplinks, which, again, is delivered by the same Ethernet leaf appliance. Or, if you are not, then you would just connect the PE router, like I said, either directly to the OLT and Ethernet access leaf, or through the spine to, you know, consolidate the interfaces. And as you can see here, we have a platform that can scale to a huge number of PON ports. Actually, for OpenReach, we deliver more, let's say, central offices with an OLT with more than almost 2,000 PON interfaces. Let me repeat it, almost 2,000 PON interfaces, which is a huge number. And all of it is seen as a single OLT. Of course, there are many OLT leaf. Actually, there are 39 of OLT leaf, each one with 48 PON ports. If you do the math, is 1,872 PON ports. And all of them are seen by a management system, which is a standard access domain controller, which for Adtran is our Mosaic platform. But of course, any SDN controller would work in the same way. So the controller is also an orchestrator. This is very important to simplify the end-to-end view and provisioning of the whole platform. So in this way, we have built a much more scalable and flexible OLT than the traditional chassis-based OLT. We have basically overcome the issues that were present, let's say, were due by the presence of a backplane. And the backplane is really the problem. So if we compare the two architectures, on one side you have a proprietary and constrained backplane. On the other side, the backplane is realized with standard Ethernet cabling. Let me say it again, standard Ethernet cabling. So it is not constrained, and it is, let's say, interworking by, say, natively, thanks to the Ethernet standard. So in this way, we deliver something that it is more simple, more flexible, and more efficient than the current architecture. Let me just show you a few of the OLT leaf. So in our case, but of course there are other vendors that do their stuff, in our case, the OLT leaf are 3-dimension, 4 PON ports, 16 PON ports, 48 PON ports. And when I say PON ports, I mean any PON port. So, for example, the 48 PON port, which, by the way, is you can see it physically at our booth, can host any mix of PON, XGS PON, or combo PON interfaces, not more than 48. And like I said, when you need more, you just stack a few of them. Also, this is for simplicity. Simplicity also means openness. So basically, the fact that we have standard Ethernet connectivity means that everything is open. What I mean is that, for example, you can have an OLT which is Adtran, but also if you need an Ethernet aggregator, you can decide that you don't like the Adtran Ethernet aggregator and you put another white box aggregator. This is possible, as long as, of course, it supports netconf and YANG, which is, let's say, the de facto standard for the OLT next northbound management interface. And also, the openness manifests itself also by the fact that our equipment, so our access appliances and spine appliances, Ethernet appliances, can be managed by a standard SDN controller, like I said before. And of course, this SDN controller will have northbound interfaces which can support any OSS. This is, in our opinion, what it means to be open. So it means also accepting some other vendors' appliances. That's, that's competition, because we are pushed to do our best every time. So in terms of flexibility, you can see here a snapshot of all the topologies that can be done, well, all the main topologies that can be done using our OLT. So, of course, it can be connected as a standalone. That thing, I mean, that black tile is whichever OLT leaf you like. I mean, the one that we have seen 3 before, whichever of those 3 can be, has the same flexibility. So it can be connected directly to the router. When you need more than that, they can be connected as an OLT star, number 4 there. Well, if you don't have enough interfaces on your router, you can either cascade them. There is no limit in cascading. The only limit, to be very honest with you, is the uplink bandwidth of the top equipment. So if you don't like that, you can create a local ring, and of course the ring can also be, a geographical ring. Only if there is the need for a local aggregation, and I say only because it's not always the case, then you can insert a Ethernet aggregator. And of course, number 6 is for very big OLT needs. For example, the ones that at the moment we have only in OpenReach in Europe. So, as you can see, this is very, very flexible in terms of topology, because we have literally decomposed the functions of the OLT. So you create basically you have another angle of freedom, okay? So that's very important in our opinion. And also it is possible to mix and match a few architectures. For example, you can have a ring, but each of the stations of the ring is actually a chain of OLT appliances. This is also possible. So let me go quickly on this. When I said before that our architecture, the disaggregated architecture, is also better to withstand the future, for example, 50 gigabit PON interfaces, what I mean is that basically keeping the same architecture and keeping the same appliances, you can add, when you, say maybe after 2030, you will need to insert 50 gigabit PON interfaces, you can just add a new appliance just for 50 gigabit PON without throwing away anything that is already installed. In comparison, a chassis-based traditional node would either, have, say, inserted the new 50 gigabit PON card in the old backplane with some big limitations, or in order to avoid those limitations, you have to wait for a new OLT to be completely developed. Because remember, designing and building a new backplane requires a lot of time. So you would have to wait for some time, and then you chuck your existing OLT, and then you have the full 50 gigabit PON capable OLT, which is, in our opinion, a waste. Let me also quickly talk about the efficiency. So, like I said, in the engineering world, it is really not a good situation when your chassis-based OLT is full. Why? Because the next requirement from the marketing that is requiring you, for example, to add a few PON ports is going to be a problem, because you normally, in that case, you would have to add another chassis. Actually, what happens is that automatically, when the OLT is, let's say, 70% full, the operations are automatically ordering another chassis. The other chassis is going to be, of course, half empty, and this wastes space and energy. In comparison, and you can see on this slide some percentage savings, the scaling way of a disaggregated OLT is much better, because you have to deploy only the appliances, which are, like I said, pizza boxes, that you need in that moment. And you are always sure that your OLT can grow organically, smoothly, from just a few PON ports to thousands of PON ports, keeping the same OLT, say, virtual end-to-end construct. So this is very important. So this is the source of the disaggregated OLT advantage in terms of efficiency. Let me just go to some results. This is a completely fictitious exercise that I made for a big European country. So I just wanted to see what is the yearly cost of energy of running a huge countrywide access network. And of course, you might recognize that the trend of the cost follows the energy cost, right? I mean, just after 2024, I have taken let's say, imposed a 5% decrease in this cost. But you can, the really important point here is that you see the disaggregated OLT is the pink one. The blue ones are two vendors of the traditional chassis-based OLT. There is a huge difference in terms of, well, in one case, there is a huge difference to a specific vendor. There is a huge difference. To another vendor, there is a small difference, but the point is that paradigm really holds. So that paradigm is still the best from whatever type of vendor. So also the difference is much more evident in terms of rack unit, so space. Also, another point that I wanted to make is about the matrix or aggregator card of the chassis-based OLT. So when before I said that the disaggregated OLT only deploys what it is really needed for the operator, I really meant it, because the matrix card, which is always needed in a traditional OLT, is not always needed, functionally speaking, for the operators. There are some cases, and this is a case in Greece, for example, where one of our customers had to deploy new switches which had a lot of interfaces available. So in that case, you don't need an aggregation function within the OLT. You can just reuse the aggregation capability of your switches. And this is an important thing, because actually it's money, it's efficiency, and it is a cost of the total end-to-end solution, which is saved by the engineering. So these are the figures of the disaggregated OLT, and this is normally what would happen with a chassis-based OLT. So basically, you have to aggregate twice, let me say, one time in the OLT and the other time in the aggregation network. It is a waste, and you can see it very clearly in the small table there. On one side, we have a power per port, which is 10 watt, not counting, of course, the switches. And for the disaggregated OLT, you save the 30% of energy, and the 20% of space is not bad. So, yeah, useless pre-aggregation. I'm almost done with the OLT. One important point, you may ask me, okay, but what about the future for the chassis-based OLT? How are they reacting, the vendors that push this type of architecture against these challenges? Well, this is a schema of the internal architecture of the chassis-based OLT versus the disaggregated OLT. So as you can see, in the chassis-based one, there are line cards, there are the switching cards, matrix cards, and there are the uplink cards. So as the capacity of the PON ports and the bandwidth on the backplane goes up, then the architecture of the chassis-based OLT is pushed towards a leaf-spine-leaf architecture. You can see it is a leaf-spine-leaf because line card, matrix card, uplink card. It is a true leaf-spine-leaf. But the connections, again, are using the same backplane. To be clear, these are not two different backplanes. These are two different connections on the same backplane. So my point is the blocking points, the problems of the chassis-based architecture are still there. So, and if I may say, they are even worse. And that's why we start seeing that the newest and most innovative chassis-based OLTs actually are hosting less and less PON ports. Why? Because the vendor has hit the, let's say, the maximum that they could do on the backplane. So basically, there is no, the holes are too close to each other, and the technology is not capable enough to go further than that. This is a problem. The same type of architecture, a leaf-spine-leaf, is always possible with the disaggregated OLT, but not always necessary. So, like I said at the beginning, you can have only leaf OLTs, pizza boxes, or you can add an aggregator, or you can add another Ethernet aggregator at the end, realizing a leaf and spine. But to be honest, the leaf and spine architecture is only needed when the OLT is very big. So that's why we strongly believe that the disaggregated OLT as an architecture is much better. Like I said, we are there with my colleagues ready to answer to your questions, curiosities, doubts, challenges. We are fully open. So let me add one last point. So I'm done with the OLT. I wanted also to mention quite quickly the fact that there is also, also a PON fiber monitoring solution is important. Why? Because fiber is an asset. It's going to be more and more important as an asset in the future years when Poland will reach, now it's 60, then 80%, then 100% of the FTTH coverage. So the fibers are there, they need to be monitored. In our opinion, the effective PON assurance requires, first of all, a non-disruptive PON monitoring, but it is, let me say, obvious. But also a very effective PON monitoring. So the fiber band or fiber break has to be detected even beyond the two splitters. And then, of course, it has to be cost efficient. So there shouldn't be the need for any reflectors at the customer premise. My numbers say that a reflector doesn't cost much, like 5 to 8 euros, but is a cost per customer, is a cost per end user. So all in all, is a huge load of costs. So the technology that we at Adtran deploy can get rid of this cost. So which is the technology that we deploy? Is our ALM platform, which, by the way, you can see in a demo, live demo at our booth. So I encourage them, I encourage you to come and visit. It just employs a coupler, a simple coupler. And by the way, I mean, it doesn't have to be a Adtran OLT, of course. It can be coupled with every other existing PON solution in the market. It's actually a different wavelength, as you know. So, which deliver 24/7 in service, non-intrusive PON monitoring, even beyond the splitters. And like I said, is the industry first and so far, to my understanding, only reflector-less solution, which of course supports all the PON generation. Why? Because it works on a different wavelength, very simply. So 1650 nanometers is the wavelength for the OTDR, which, as you can see, is actually, say, far away from any PON technology, also considering the guard band. So it's a very safe technology and also very efficient, because it is capable to see the fiber cut or fiber band even after the splitters. So we believe that this type of technology is going to be more and more important to the operator as the deployed fiber is getting bigger and bigger. So, like I said, this is also available, in this case, also to see live working in our booth. One last thing, and then I think I can leave you to your deserved lunch. So, one last message is we support Poland. We support the Polish ambition to reach full fiber and to meet the European digital agenda targets, which, let me repeat, is 1 gigabit per end user by 2030. Very challenging. In order to do that, we provide a disaggregated OLT, which delivers the advantages that I mentioned to you: simplicity, flexibility, and efficiency. Also, we proudly provide an integrated optical line monitoring OTDR system, which is very effective without the need for reflectors. And we are there to support this country, and also we are there today to answer to your questions. Thank you very much.